Okay, welcome back students to the Maclaurin series and Taylor series. In this question, as you can see that the center is a equal to 2. Now, if a equal to 2, this is what we call it the Taylor series. If you haven't watched part 1, please go back and watch it because it will really help us here. Now, what we need to do, Taylor series, we need to write f of x equal c0 plus x minus 2, because 2 is the center, c1, c2, x minus 2 square, c3, x minus 3 cube, c4, x minus 2, 4, and so on. And as we did last time, in order to find what is cn, we need to find the derivative of the function, and we substitute it at 2 because 2 is my center, and we divide it by n factorial. So what we'll do now is we'll make a table, little one here. And here is the derivative. And here is the derivative at 2 exactly. And here will be the cn, which means the derivative at 2, and we divide it by how much in factorial. So we will do the first maybe 5 terms, and we see the pattern as much as we can. Now, what is my 0th derivative? It is the function itself. So the first derivative is 5x4, 9x squared plus 1. Next derivative, 20x3, 18x. Next derivative, 60x squared with 18. Next derivative is 120x. I think I need to take the 5th derivative. It is 120. And then it will be just 0. So I can see the pattern is that this will not be an infinite series. It will stop at certain number. Now, if we substitute the 2 up here, what we will get is 2 to the power of 5, and then 2 to the power of 3 plus 2. This will give me 58. The next one will be 5 times 2 to the power of 4 plus 9 times 2 to the power of 2 plus 1. And that's 117. Next one will be 20 times 8 plus 18 times 2. And that's 196. And then we will be 60 times 4 plus 18, 258. And then we have 120 times 2, 240, 120, and then 0. Now for each one of these we have to divide by the n factorial. So this will be 58. This will be 117. Now 196 divided by 2 factorial, this is 98. Now 258 divided by 3 factorial, this is 43. Now 240 divided by 4 factorial, this is 10. This is 1, and those are zeros. So I think everything is straightforward now, and the Taylor series for this one will be 58 plus 117 x minus 2 plus 98 x minus 2 square plus 43 x minus 2 power 3 plus 10 x minus 2 power 4 plus x minus 2 power 5. And that's it. So you don't need to have a series. Sometimes the Taylor series is not a series, but again, this is what we get. Now, you might get confused that how can I write polynomial in a different format? That would be fine because here we changed the center. Okay, so just follow the steps, everything should follow up the same way. If we have another questions, maybe similar to what we did, this one with the cosine, maybe we can try it. So here a little bit, I will go quick with this one. So it is f of x, which is cosine x. It will be c0 plus c1 x minus pi over 2 plus c2 x minus pi over 2 squared, c3 x minus pi over 2, 3, and so on. Again, we need to make our table up here. Zero, 1, 2, 3, 4, 5, 6. And then the nth derivative. So we start with cosine x. Next derivative is minus sine x. Next derivative is negative cosine x. Next derivative is sine x. And then I will get back to cosine x. Let me do it in a different color so that you can see what's going on here. Now you can see that I will repeat what I did before, because look, once you end up in cosine again, whatever come next will just repeat itself. So it will just be minus sine x, minus cosine x, sine x, and then I will get back into cosine x. Let me go back to the white color. And so on. So the pattern is easy, we can see it because at every 4 steps we go back to what we started with. So let's focus on the first part, and I think the rest will follow. The next one is we have to substitute pi over 2. So this would be 0, negative 1, 0, 1. And as you can see, this has to repeat itself. So it would be 0, negative 1, 0, 1. And so on. As you can see clearly here that the odd will survive, the even will be vanished. Keep in mind, the odd, they are surviving and they are also alternating. Keep in mind, it's negative, positive, negative, positive. So we have alternate, that's the first remark I can see, and it's only odd. Keep this in mind, it will be useful in a minute. Finally, we need to find Cn. Cn is the nth derivative at pi over 2 over n factorial. This is 0. This is 0, 0, 0. Now, those are what? It will be negative 1, 1 over 3 factorial, negative 1 over 5 factorial. This one will be 1 over 7 factorial. Can you guess what would be the next one? Exactly. It will be 0. And after 0 will be negative 1 over 9 factorial. Why this is negative? Because it's alternating series here. So finally, we write the final answer. Cosine x can be written as negative x minus pi over 2 plus 1 over 3 factorial x minus pi over 2 power 3. Only the odd. And it's alternate. So if we just put everything together, what we have is alternate. This is for the alternate. We have odd factorial, and we remember we said odd is 2n plus 1, and then we have x minus pi over 2 to the power of odd. Okay. I think that's what we want to say up here, and that's the idea. Now what we will do in the next video, part 3, we will write the formula that you need to know for the famous functions. We already have seen the Maclaurin series for 1 over 1 minus x, tan inverse of x, ln 1 plus x. Go back to section 11.9 and you will see that we already have them. Today we want to write 3 formulas for the 3 famous function ex, sin x, cosine x, and that will be in the